these components, it looks like we are going to process.
Correct.
3/8. And then this 1/2 inch ring, I assume you want that cut.
Yeah.
So now it's going to, process the stuff we assign material to and not process the other parts, which is nice too, because, in the case that something is drawn as angle iron, but you want to cut it out as a sheet metal, it will convert that to sheet metal. Even if it's drawn as angle iron, we can force it to cut as sheet metal. If that's something that you want to try doing at some point.
Sure. There are times that we just make basically angle out of a flat sheet sometimes, so that's good to know.
Yeah.
Mm-hmm.
You can tell it either way if you're.
You can force it, even if it's imported as an angle for whatever reason. You can force it as a sheet metal. Yeah.
Yeah. So if it's like I have a demo part I bring in that has no bend radius, I drew it as an extruded boss in SolidWorks. Not drawn as sheet metal. You cannot create a flat pattern in SolidWorks. It's just an extruded boss. You bring it into this software, it converts it into a bend immediately. It calculates the bend deduction, looks at your press brake and your press brake tooling, and then gives you a good flat pattern.
Mm-hmm.
So this one, we'll go ahead and save this one in there too. Why not?
Assumed a wrong bend deduction or bend radius, but then your tooling tells you need this. How does it?
That's a good question.
What was that question about bending?
Yeah, so I guess
What if your model is drawn assuming a certain bend radius, but then when you pull that model, that assembly in, and you're analyzing it, and you say, well, here's my tooling to use. I want to use this tool. What if that bend radius conflicts with the assembly, how the part was actually drawn?
Well, I mean, if it's drastically different, like, you have a part that's drawn with a 6-inch radius, and then you bring it in and tell it you're using a tool that's going to do an 1/8-inch radius. Obviously, there's going to be some design, it's going to change the, something's got to give at that large of a discrepancy.
Yeah.
And it's going to apply a change. Now, if we're talking minute differences, that's kind of what the purpose and function of the software is. Because a lot of times people that are, for example, one of the plants I worked in, every single part from engineering got drawn with the 16 thousandths inside bend radius because that made the models work really well. Now, whenever we would go and manufacture it, obviously with 1/4-inch material, you're not going to achieve an inside bend radius of 16 thousandths no matter what tooling you utilize. So when we bring it into the software and the software basically introduces the model to reality. So then it would automatically adjust that bend radius to what reality is going to be based on the tooling. And if there's like a hole that's close to the bend line that's now going to be distorted, we're going to get an alert of that. It's going to notify us that that's going to happen. And now we can decide, are we going to go ahead and continue to manufacture this part, or are we going to go back to engineering? Either way, it's going to distort in reality. We're just learning what reality is before we ever cut a part out.